Hi all, today we'll discuss about synchronous and asynchronous data transfer. So synchronous means at the same time. So in this format, the data transfer sender or transmitter and receiver devices both are synchronized with the same clock pulse. So if this is my sender and this is my receiver, the sender sends the data, and before sending the data it looks for a clock pulse. So clock pulse is something like this. This is 0 or 1, 1 and 0. This is called transition period. So during this transition period, any micro operation or any task will be initiated during this transition time itself. So they share, if the both sender and receiver makes a commitment that the sender starts sending the data during this 0 to 1 transition period, the data is transferred to receiver, and during this 1 to 0 transition period, the receiver receives should expects data during from 1 to 0. The sender sends the data from 0 to 1 transition period, and receiver accepts the data during 1 to 0 transition period. This is called at the same time. This is called synchronizing means. Next, again, the sender sends the data when the transition period 1 to 0 to 1 happens. Same way, the receiver receives the data when the value 1 goes to 0. So this is the concept of synchronization means, and they share the same clock pulse. They are synchronized with the same clock pulse. So clock pulse in the sense they both are sharing one common clock. If the sender and receiver are very nearby, they share a common clock pulse. So this is one common clock pulse where this is 0, 1, 1 to 0. So this is called one common clock. So during this common clock, 0 to 1, 1 to 0. So this is called one clock pulse. So during 0 to 1 period, the sender sends the data, and during this period data is transmitted, because data transmission also takes some time, and when it reaches the clock pulse 1 to 0, then the receiver expects the data during this period, and this is repeated for several times. This is called synchronous data transfer. So it is used, the synchronized data transfer is used in between the devices that matched in speed. See this. During one clock pulse, sender sends the data and receiver receives the data. Remember? This is my sender, this is receiver, and this is data transmit. So during this one clock pulse, data has to be transferred. Sender should send data, receiver should receive the data, and this is transmission time. Similarly, for the next clock pulse, again from 0 to 1, sender sends the data. During this transition, data is transmitted. Again, during this 1 to 0 time, receiver receives the data. So this cycle goes on until the data at the sender side is completely transferred to receiver. But the point here is this synchronized data transfer is applicable for the devices for where the sender and receiver, they should match in the speed, because during one clock pulse everything should happen. And the next clock pulse again the sender sends the data and the receiver has to receive the data. So the speed of the sender and receiver both should be match, and it is invariably used in between memory and microprocessor when they are compatible. So the best example for synchronizing in synchronized data transfer sender and receiver is the communication between processor and memory. So you might be getting confused, what is this sender? Sender can be a processor and receiver can be a memory. Memory in the sense main memory. So the speed of the processor and main memory are almost same. They match with the speed. So the best example for synchronous data transfer is the data transfer that happens between the processor and the main memory. Is the best example for synchronous data transfer. Next we'll see in synchronous transmission, data transmission is carried under the control of a common master clock. So as I said, as I drawn earlier, if this is my sender and this is my receiver, there is a common clock. So both sender and receiver works on the common clock. They share a common clock. And bytes are transmitted as a block in a continuous stream of bits. So if the sender, let's assume this is my processor and this is my memory. If the processor wants to send 1 byte of data, then this 1 byte are nothing but 8 bits. These 8 bits are grouped into one block, and these blocked 8 bits are sent continuously during one clock pulse. So during one clock pulse, 8 bits has to be transferred, and the sender should receive those 8 bits. The transmitter and receiver operate at synchronized clock frequencies. So synchronized means as I said earlier, so this is one clock pulse. This is called one clock. As I said earlier, they share one common clock, means this is called one clock pulse. It is very important to understand this concept of clock pulse. Remember, during transition period itself something happens. So when 0 becomes 1, during this transition period, sender starts sending the data. During this transition period, the value 0 to 1. And during this time, what happens? Data is transmitted. So during this period, 8 bits are has to be transferred as a continuous. So the receiver expects a, so during this transition, again transition from 1 to 0, so during this transition period, that is 1 to 0, so during this period the receiver expects total 8 bits. So during this period, that is 0 to 1, sender sends the data, and during this period Total 8 bits are transmitted. 8 bits are. So this is the concept of synchronized clock frequencies. So both transmitter and receiver operates on synchronized clock frequencies, means this you should understand. And here no start and stop bits are required, because the clock, by looking at the clock itself, one can say, because when 0 to 1, during this period sender has to send 1 byte, that is 8 bits. So during this period, next when 1 becomes 0, the receiver expects those 8 bits. No start and stop bits are required in case of start and stop bits are not required for synchronous data transfer. So in case of synchronous data transfer, no start and stop bits are used. No need of ideal time between data bytes, because it's a continuous process, right? It's a continuous process, and there is no time delay. No need of ideal time between data bytes. See, during this one clock pulse, 1 byte is transferred. The second clock pulse, second byte is transferred. There is no delay in transferring the data bytes. So in synchronous transmission, timing of signal is important. See this. What should be the duration of this clock pulse is the most important point, because during this clock pulse itself, three things should happen here. One, sender has to send the data, total data has to be transmitted, and during this 1 to 0, receiver has to receive data. So the length of this clock pulse is most important one. It should not be too short, it should not be too high. That is the most important thing in synchronous data transfer. Let's take some diagrammatic representation of this synchronous data transfer. So here we have a sender. Here I have a sender and 8 bits. 1 byte means 8 bits. They are transferred in one clock pulse. These are transferred in second clock pulse. These are transferred in third clock pulse, fourth, fifth. So like this it continues. So there is no start and stop bits. Only the thing is, during this clock pulse, during these clock pulses, sender sends 1 byte, receiver receives 1 byte. So the length, how much should be the length of this clock pulse? It should not be too short or too high. It is very crucial to decide how much should be the length of the clock pulse. That is the most important thing. That is called timing signal. It is very important in synchronous data transfer. So in synchronous transmission, we send bits one after another without start and stop bits or gaps. It is the responsibility of the receiver to group the bits. Now let us look at asynchronous data transfer. So asynchronous means at regular interval. Synchronous means at same time, whereas asynchronous means at regular interval. So now let us look at Asynchronous data transfer. Asynchronous means at regular interval. So in this method of data transfer is not based on predetermined timing pattern or timing signal or clock pulses. In this technique, the status of the IO device is checked by the microprocessor before data is transmitted. So the best example for the sender and receiver is that sender can be your processor and receiver is your IO device. One thing you should understand when we discussed about need for IO interface, the speed of the processor is high, very much high compared to the speed of the IO devices, because the IO devices are electromechanical and electromagnetic devices, whereas your processor is a complete electronic devices. So there is a speed mismatch. So before processor sending the data to IO device, first processor checks the status of the device, whether the device is ready, then it sends the data. So it is used in between the devices that are not matched in the speed. The best example is processor and IO devices. Invariably used in between the microprocessor and IO devices. The best example for asynchronous data transfer is the sender in asynchronous data transfer can be a processor and the receiver is an IO device. So in asynchronous transmission or asynchronous data transfer, the sender or transmitter transmits the data bytes at any instant of time. There is no common clock, so there is no clock pulses concept called clock pulses. So in the clock pulses case, what happens, only in this duration the sender has to send the data, but in case of asynchronous data transfer, nothing like that. The sender can send the data at any time. The only thing is it has to make sure that the receiver is ready. So the sender can send the data at any time. Only one byte is sent at a time. There is some ideal time between two data types, data bytes, because when a sender sends one byte, it gives some gap, then it sends one byte, again send gap, one byte. Because the speed of the processor or sender is very much high compared to IO devices, or the speed of the IO device is very much low, so it cannot send continuously. It has to send a one byte of information. The processor, sender means the processor, example, processor has to send one byte of information and give some gap, some ideal time, again send one byte. The transmitter and the receiver operate at different clock frequencies. They can have their own, processor can have its own clock frequency, IO device can have its own clock frequency. To help receiver, then receiver don't know when the sender sends the data. The problem in the asynchronous data transfer is that there is no prior information to the receiver that it is going to receive some data. For that, we are using some special bits just to help the receiver, that if the receiver a particular bit, then it is kind of prior information to the receiver that yes, I am going to get some data. So if this is my sender, if this is my receiver, first receiver sends start bit. With the receiver receiving start bit, it understand that yet then it is getting some data. So send the data, then send one stop bit. So this is how asynchronous data transfer works. So the speed of the sender, that is processor, is different or very high when you compare with the speed of the IO devices. So here what happens, first start bit is sent, then send the data, then send the stop bit. So the start and stop bits are just to help receiver that when data is going to start and when that it is also equally important when the data is going to stop. So the start bit and stop bits are used along with data in the middle. Ideal time between the bytes is not constant. They are also known as gaps. So the ideal time between the byte is not fixed or constant. It can be, the gap can be too high, can vary. So in asynchronous transmission, timing of signal is not important because you are not, the sender is not going to send at fixed intervals. It can send at any time. Then how can the receiver know that sender is going to send the data? By using two special bits. One is start bit and the other is stop bit. Let's look at as a diagrammatic representation of asynchronous data transfer. So this is my sender. So this is called, best example is processor. So it contains a start bit and stop bit in between the data. In between this is 1 byte of data. This is called start bit and this is called stop bit. See, this is 1 byte of information. This is called start bit. This is called stop bit and this is 1 byte. And see, these are the gaps, and gaps need not be same. The receiver is nothing but IO device. So I hope you are understanding this point. Can you imagine what could be the problem with the asynchronous data transfer? Yes, if the start bit is lost during transmission, then there is no way that receiver knows that it is going to receive a data. So this is called error transmission. This is called transmission error. So it is very important to handle these transmission errors in case of asynchronous data transfer, because see here the start bit is 1. So this 1 indicates that the receiver understands by receiving the start bit 1 that it is going to receive some 1 byte of data, 8 bits. After 8 bits, send some stop bit. So the thing is, okay, start bit is 0 here, stop bit is 1. If because of the transmission error, start bit supposed to be 0, if 1 is sent, then the receiver understands that it is a stop bit. So it doesn't expect, it thinks that the receiver understands that no more data will be transmitted. There is some gap, but the sender already, since the sender already sent one start bit 1, it starts sending the data. So these kind of error, transmission errors, handling of transmission error is the most important thing in asynchronous data transfer. So in asynchronous transmission, we send one start bit at the beginning and one stop bit at the each byte, end of each byte, and there may be a gap between each byte. So the important thing in asynchronous data transfer is how to handle transmission errors. First, receiver has to identify that error has occurred. How it's supposed to receive a start bit 0 but actually received a 1. So there should be some techniques with which the receiver should identify that it should receive a 1. Simple logic. If the receiver remembers the earlier stop bit, that it has received stop bit, after stop bit definitely it has to receive a start bit. So if it received one stop bit 1, again it is received one stop bit 1, means it is wrong because it has to receive a start bit, that is 0. So this is one simple technique with which receiver understand that the error has occurred. This is called error detection. Another thing is error correction. It's supposed to receive 0 after 1, that is start bit after stop bit, but it has received 2 stop bits. So it is, with this the receiver can can do both error detection and error correction. So there are a lot more things, a lot of techniques are available to handle this error detection and error correction. But remember one thing, in asynchronous data transfer, the most important thing is to handle transmission errors. Okay, this is about the errors related to start bit and stop bit. What if the case is that if the transmission error occurs during sending the data itself? Remember, data contains 1 byte. 1 byte means 8 bits. Instead of receiving 0, here error means only one thing. Instead of receiving 1, it might have received 0, or it might not receive anything at all. There is also one possibility. This is called data lost. This is due to the physical damage of the communication wires, as we discussed in serial transmission. But if there is no damage in the wire, still the transmission error can happen. That is, instead of receiving 0, the receiver might have received 1. So handling these things can be handled. Transmission errors can be handled. So we discuss about different techniques in asynchronous data transfer. In computer systems, CPU and I/O interfaces are designed independently of each other. Remember, I/O interface, an interface which uh, communicates, which provides communication between the processor and I/O devices. When internal timing in each unit is independent from the other, and when registers in interface and registers in CPU uses its own private clock, then we need to go for asynchronous data transfer. So with this we understand as the registers works based on the clock pulses. In that case, two units are said to be asynchronous to each other The CPU and IO devices must coordinate for data transfer. So in asynchronous data transfer, the sender and receiver, this is processor and this is an IO interface. Remember, IO interface also contains some registers. Processor also contains some registers. These registers works have their own clock frequencies. Clock 1, clock 2. Then in this case, it is required to have asynchronous data transfer technique. So now we will see different methods used in asynchronous data transfer. The most popular one are two types of techniques. One is strobe control and the other one is handshaking. The strobe control, this is one way of transfer, that is by means of strobe pulses. This is only one way of transfer. So this is only one way of transfer, that is by means of strobe pulses, by means of strobe pulses supplied by one of the units to indicate to other unit when the transfer has occurred. Remember, in asynchronous data transfer, we said that we will use one start bit, data, and stop bit. So whether it is a stroke control or handshaking, whatever it might be, start bit and data and then stop bit. So whether it may be strobe control or handshaking, whichever might be the method, the point here is they have to follow this procedure. First you should send some signals saying that we are going to send the data, that is start bit, and transfer the data and then stop bit. So the start bit, data and stop bit, this is compulsory whether it is strobe control or handshaking. So in case of strobe control, what happens, there is a separate signal called strobe signal or strobe pulse. This acts as a start bit, and this is one way of transfer. And next, another technique is handshaking. In handshaking, this method is used to accompany each data item being transferred with a control signal that indicates the presence of the data in the bus. So here what happens, when the sender is sending some data to the receiver, then the data contains some control signal. So this method is used to accompany each data item being transferred with a control signal that indicates the presence of the data in the bus. The unit receiving the data item responds with another control signal to acknowledge receipt of the data. So this is the main difference between strobe control and handshaking. So in case of strobe control, what happens if this is my sender and this is receiver? Example is here I can use processor. Here it can be an IO interface. First it sends some strobe signal, send the data, again some signal. The receiver, it is one way of transfer. Receiver is not sending back, receiver is not sending back any data. It is not happening in strobe. But when it comes to handshaking method, sender and receiver, when sender sends the data, it contains some control signal with which receiver understand that yes, it contains some data. Once it receives the data item, then the receiver responds with another control signal. This is called acknowledgement. So in handshaking, there is no sender and receiver. Both can be sender and both can be receiver. So this is the major difference between handshaking and strobe control. I will explain once again. If this is sender and this is receiver, when it sends the data, it contains data plus control signal. So then the receiver responds with acknowledgement. So there is no concept called sender and receiver. Both can be sender, both can be acts as a receiver. This is called handshaking. Now let us discuss the strobe control method of data transfer. So this is the diagrammatic representation of strobe control. The strobe control method of data transfer, what happens, it uses a single control signal for each transfer, that is called strobe. The strobe may be activated by either source unit or the destination unit. That means let's take the source unit is called a processor and this is an IO interface. First source unit starts sending strobe, then it starts sending data. The destination unit understands that as long as source is sending strobe, then it also contains data. So once the source stops sending the strobe, the destination unit understands that there is no more data to be transferred. And the point here is strobe can be initiated by source or sender. This strobe can be initiated by destination. That means if it is a source initiated strobe control, first strobe signal is sent by source. If it is a destination initiated strobe, then first destination sends strobe. So the strobe control method again can be divided into two types. One is source initiated and the other is destination initiated. So if it is a source initiated data transfer, let us understand a special diagram called timing diagram. The data bus carries the binary information from source unit to destination unit as shown below. So this is called a timing diagram. Here this says that data is active, then it is called valid data. Data has been transmitted. Once it is not a valid data. So this is called data bus. So the source or sender, when it first places the data on the data bus, so first what happens? Step 1, source places the data on the data bus. So the source places the data on the data bus. For that reason, first this is active. Once it places the data on the data bus, then again it sends a signal. The strobe is a single line that informs the destination unit when a valid data word is available in the bus. So that means if this is my source, if this is my destination, this is the data bus on which you will send some data, and there is also another signal, another line which is called strobe. So this line is used to send strobe. So strobe is a single line that informs the destination unit when a valid data word is available in the bus. So what's happening here? First, source or sender places the data on the data bus, then it sends the strobe signal. As long as strobe is active during this period, you can send the valid data. Or as long as the receiver receives the strobe signal, it understands that data is present in the database. The moment the strobe signal, the sender stops sending the strobe signal, receiver understands that there is no valid data on the database. So this is how the strobe source initiated strobe works. Remember, strobe is a single line, separate line that sends some signal to the destination. source initiated source unit first places the data on the data bus. After a brief delay, to ensure that data settle to a steady value, the source activates Strobe pulse. So it gives some gap and then sends. First it places the data on the data bus. Let the data on the data bus is active, then source sends some Strobe pulses on separate line. The information of the data bus and the Strobe signal remain in the active state for a sufficient time period to allow the destination unit to receive the data. So the information of the data bus, the data in the data bus and the Strobe signal remains in active state for a sufficient time period to allow the destination unit to receive the data. The source removes the data from the bus for a brief period of time. Then after it disables its strobe pulses.